So, hi everyone. My name is Henri Sjo, and I'm coming from a company called Trendion, and I'm working in TVO right now in a software project, and we provide vibration monitoring systems. But this project is which was my thesis project. It was done. I was employed by Elomatic, and it was contracted by Force to do this, and I worked closely with TVO that project, and it provided guidance to me, and was also was used data from TVO was used to pilot the project. So the subject is this DIAM problem-solving method, and turning it into tablet software program. And some of you might be familiar with the DIAM process, but I will first give a brief introduction to the DIAM project, the background and the previous work regarding that, and also the terminology, what it stands for. And I don't have an Excel demo for now, but because I have the presentation PC, but I will give you explanation, and I will give you some pictures to look at. And then I will explain the design of the program we have designed and developed, and the development work was it's not quite yet finished, but there's a room for improvement. But databases and user interfaces and flow of the program is designed. And I will give you some concepts of the user interface and how the program is used, or should be used. So, for the background, this DIAM project started here in Henri Sjo's vibration program as a research and development program, and there's two Nordic power plant operators included in this, and the idea for this Excel tool, this DIAM, came from Pausmakers from TVO, and the idea is that it provides systematic problem-solving approach for vibration problems in nuclear power plants. But the DIAM process itself can be used for any problem solving in general. But and as for the background for myself, I'm software developer, and my background is in information technology. So I will direct if you have any vibration-related questions, I will direct it to someone who is more knowledgeable than them. But my program is more like I will provide framework for the vibration problem solving. But yeah, there have been multiple thesis projects and research projects regarding this Excel problem solving tool, and some of you might be familiar with these projects, and some of you are here present. And if you have, and these projects have different targets for different types of components or different problems. So those are there. So these projects, as far as I am knowledgeable, these projects are tuned by Henri Sjo. There's this steering group which have tuned these matrices and problems regarding them. So this DIAM, it stands for Detection, Investigation, Analysis and Mitigation, and it's a general problem-solving process for. It has been developed for vibration problems, but my understanding is that it can be expanded to any kind of problem solving, and not just for nuclear power plants. It can be any kind of power plant or facility. And there's big part of the problem-solving process is to investigate detected anomalies, and they might turn out to be nothing, but it's something that might be in something of interest. And with this tool, it will provide suggestions for further actions, and I will give you an example of that. And there's this probability-based function which provides the suggestions. Forward. So here are the 4 steps in the DIAM process, and these steps are meant to be followed in this fashion. And I've also included this brief step before the detection, and it is to provide information about the component we are inspecting. So in this phase, for example, if we are inspecting a pump or a diesel generator, we might input with some special characteristics of that device or component. For example, running speed, frequencies, and we can calculate values based on any of those values. And then we start the actual DIAM phase. So the first we have a detection, and that's where when we are doing inspections in a power plant, we might hear some noise or some frequency, or we might spot leakage, or there might be some sensor which sends alert or something like that. So that's an anomaly, and we will indicate that anomaly, and based on that, we have suggestions what might cause that anomaly. It might turn out to be nothing, or it might be some known phenomenon. And in this phase, when we have spotted the anomalies, we will indicate them, and we will determine if we have to proceed to the next steps, or we might need to do something else. So then we go to the investigation phase. So then we are suggested with further methods which we can implement or do to further narrow down the root cause. So the actual phenomenon which is causing the anomaly, and this might be making further measurements with instrumentation or things like that, but something to do at the power plant overall. And after this phase, we should have narrowed down the possibilities or the possible root causes. And if the root cause is still not clear, if the initial anomaly is not like clear, we can do further analysis. And this phase is more generally done by the outside third party. It might be supplier of the component, or it might be third party consultant or something like that. But it should be pretty much expert in the field related to that component or root cause. And after this analysis phase, we should have found the root cause for we will indicate that root cause, and in this final phase we have suggestions for mitigation methods, and all of these suggestions can come are provided by the probabilistic function.
May I ask a question?
Yeah, sure.
The pre-step and the detection, is it when you come to the detection that you start working, or have you done work before? Do you have to have an anomaly?
Yeah.
Do you have to have a disturbance in order to start this, or have you started it before?
Well, it could have been started before, but generally, if there's like a scheduled inspection you do, and if you do not detect anything, you don't need to do anything in this step. But in general, if you do have some anomalies, you start from this step and work your way through, and that's one problem detection chain stored at your, or it's in your disposal.
You would think if you have a pump, the pump can run at different frequencies. It has a different number of blades. So what you do in the pre-step is you characterize your pump. Otherwise, your connection, your detection or investigation isn't coupled to that specific pump. So you're like characterize a specific pump, a specific piping, or whatever.
Yeah, it's good compromise.
So you haven't been doing much more than you make your empty matrix or your.
Yeah, I will provide example when these phases are gone. And here at the bottom, you can see responsible parties who would be making these steps. So generally, these steps would be on site by the power plant personnel, and this step might be from supplier. But sometimes we can skip this phase if the anomaly or problem is widely known, and we can just make detection. It will provide some number of root causes, and we can clearly say, oh, it's that one, and we can skip these steps and come to the mitigation. So these steps are just to narrow down or eliminate some causes. Yeah. So these DIAM matrices are implemented currently as a Excel sheet, and each Excel file or each Excel composition covers one type of component or one type of problem. And currently, I think we have three. There's one for pipe related components, and then problems. There's turbine DIAM and emergency diesel generator DIAM. And each step, as you've seen previously, each step is associated with one matrix in the Excel, and also the pre-step, which included input data for the component, is also one sheet in the Excel, and it should be inputted first when one starts using the Excel. So during the step, for example, detection step, as markings are made. So each step essentially boils down to indicating what is the problem, and it's done with the or done in the yellow row in the matrix, and it's done by marking X into the spot you have detected. and these are the steps. Actually, the investigation step is or consists of multiple sheets and suggestions. First, there's a suggestion of objectives, which are the targets, what can be found, or what can narrow down the root cause of the phenomenon in the end. So based on that, we are suggested with investigation methods, and based on expertise or analysis or something like that, we select the number of methods, investigation methods, and based on findings of those methods, we indicate the findings with a similar Excel sheet like this. And at that stage, when the indication is made, the root cause suggestions are narrowed down. And in the mitigation phase, the root cause should be clear, and we indicate that, and based on that, mitigation methods are suggested. So in the next slide, I would have better description of the Excel sheet. This is the detection phase. I don't have the actual link to the Excel sheet because it's not in the presentation computer. But essentially, the steps boils down marking findings to this row, and when the marking is made, we are provided with the probabilities, and these are the highest probabilities are the one you should be focusing on. So, and these are the weights which are used in the calculation of these probabilities, and these are the weights that are tuned in the energy vibration steering group. Yep, and then here's some motivation why we decided overall to develop and design this DIAM matrices in tablet and desktop PCs, such as now the Excel implementations will cause some difficulties or inconveniences, and for example, the data is stored when you are doing an inspection, and you are conducting this one DIAM chain, starting with detection and investigation and ending up in mitigation. That information is stored only in one Excel file, and when one starts having multiple of these inspections keeps piling up, and the amount of Excel files you end up with starts to be quite big, and it's not easily to manage. For example, if we want to find what are anomalies we have detected in one component in one specific plant, it's not easy to go through all the Excel files and find that information. Or if we want to further find what are similar components to this in other plants or same plant, we can in application level we have all these things stored in a database, so they are much more easily accessible, and you can build applications on top of that. So that covers this maintainability point as well. So storing information, that kind of information in a database, it's much more easy to, it's more easy to maintain and use for further use. And for user guidance, the Excel files provide you with pretty much. It shows you where you need to do the markings, but it's not more advanced than that. With the application, you can have different user interfaces, restrict access to some data, or it will give you a view-by-view based workflow for going through the steps. And regarding this visible information, we can, for example, if I go back to this one, this Excel file is actually much more longer than this, and currently all we are interested in are these percentages which are marked green, and we can also threshold that we want only phenomena which are over 5%. So with application level, we can narrow down the visible information to significant information only. With the Excel, you are stuck with huge matrices which might expand and expand. And workflow, it's simple in Excel, which is good, but it's not that flexible. In that application, we can make use of interfaces, and we have desktop side and tablet side. We can provide each interface with more appropriate interfaces. And as I mentioned, the use of historic data for if we want to access it might be whatever detected anomalies in this plant, or what has been detected during these 5 years, and what have been mitigation methods for those problems. It's much more easily to access that historic data with the application level. And as for the users, this is intended to be, or Excel is intended to be like an expert tool that only migration experts use. With the application, we can separate the application into components that are for use, like inspection personnel, and then data can be transferred to migration specialist, for example. And that's pretty much the motivation why we started designing and developing the program. And next, I'll have this workflow. This is to reflect the previous workflow I shown with the Excel. So it has the same steps: detection, investigation, analysis, and mitigation, and they correspond to some functions in the application side. So first of all, the application is separated into two distinct environments. One would be the office, where desktop or laptop or some PC is used, and we use it with big screens. And during the inspection, we are at the plant, and we only want to carry small tablet or something to do the work. So overall, this this is like a pre-step before the detection phase. We have the tablet in the office, and we ensure that it's synced with the main database, and we start the inspection route. And during the inspection route, we might have switch of personnel who is using the device. And during detection phase with tablet, all the anomalies are indicated on the tablet, and then comes the part when we, or the person who's doing the investigation, can, based on the findings, do further investigation based on the instruments he has with him, or they are otherwise available. He can do the investigations based on the suggestions and mark the findings during the same inspection route. So there's no need for to come to office and update the Excel and then see, oh, I need to make this measurement and go back to the plant and do the inspection. So this is to make this more fluid or flexible. And then there might be few steps where the investigation analysis are investigated. It might happen in a plant, or it might happen in an office environment. All these steps can be used in any environment, but this is the most common workflow.
Henri, may I ask a question there?
Yeah, sure.
What do you mean by third-party analysis? Is it just a third person, or is it a...
It might be like a supplier sends a consultant, or it might be contractor from outside.
Okay, and general, okay.
Yeah. So it's just like this step. And
so it's not a third-party audit?
No. No,
that's why I was just checking.
No. So regarding that, I've used like this fading color here just to indicate that different operators might have different capabilities doing inspections themselves. So they might need to contract, or if they have the knowledge and equipment, they can do the analysis part themselves, or these are like, or not set to stone. Is which party does which thing. So these are like intended to be flexible. And the same thing goes for the Excel side as well. But here we can have more advanced user roles. So we might have the people that are working at the power plant, people who are vibration experts are working from office, and we might have outside consultants, and we might have a supplier, and then the maintenance personnel which are doing the mitigation and repair work. So yeah, this is just to indicate that when the third-party consultant or supplier is doing the analysis part, they might conduct some investigations themselves, which will hopefully end up with the result that there's only one root cause remaining, and then the mitigation is made. And during this phase, all of these steps are stored in the database. So everywhere that it says that there's marking or marking findings and marking mitigations, all of these things are stored in the database. So there's should be more detailed explanation. So this is the tablet device here, and it's used to start the inspection route. So it's carried out to the plant, And inspection routes are consist of locations which are inspected, and each of those locations we might have a anomaly detection. And based on the previous workflow, the person doing the inspection might do further investigations and mark findings, but in the end of the inspection, we have some collection of these indications. And when the tablet is brought back to the office, it's synchronized with the main database. So then the information from the tablet is available for everyone using the program. So in this stage, we might have a situation that we have detected anomaly and we have narrowed down the list somehow. So the next step would be to some expert to use the expert user interface, and that comes from the main database, and because all the information is stored in the main database, and based on that, when the expert user interface is opened, it will provide the empty Excel sheet and populate it with data from a database. So this Excel interface is used as a viewing tool for the data, and actual storage is here in the database. So if the further markings or indications are done here, they are not saved in the Excel file, but they are reflected back to the database, and all the data is stored there. So one reason is to use the Excel was it was simple to provide this interface. This interface, we have some difficulties with some other user interfaces, and this provided like fast and development route for the that side of the desktop side of the interface. So this is a slide regarding the database and the pre-steps. So pre-steps before we can start these DIAM inspections. So these are areas that need to be created and connected together in the database, and we have user interfaces to do these connections. So first of all, we need information about DIAMs, which we already have. So that would be the diesel generated DIAM, pipe DIAM, and turbine DIAM. And essentially, all these configurations are essentially lists of different anomalies. So turbine DIAM consists of anomalies that are found in the turbine component, turbine and related components, and there's specific investigation methods that are used for this. So these are collections or configurations or different anomalies, phenomena, investigation methods, investigation objectives, and analysis methods and mitigation methods, and of course all the weights between them. So these all have their own probabilistic network. And after that, regarding the inspections, we need to create component types. Type can be configured as you like, but we have decided to create component types based on certain type of, for example, diesel generator. It might be some model, usually model of that component, or it might be with pipe elements. It might be some type of pipe or things like that. And these component types are associated with one diam. So when we are working with installed components, which are the actual components with certain serial numbers in a plant, we can with the connections we have, we can specify what type of diam we are working with, and all the suggestions are based on that. So these are just indications that there would be collection of these in the database, and these would be, of course, would be specific to each plant and each site. And next slide, I have a few same types of or areas as well. So these are regarding the inspection route I showed you in the previous slide. So these installed components with the serial number are then connected to a plant and maybe building, maybe some position. This is the most critical part, is the position in the plant. So these would be, if I go back here, these would be positions, would be component position in the plant, usually indicated by some identifier. And if I go back here, the inspection routes, which are specific to each plant, they are constructed to be one or group of locations on a plant. So when we are conducting a route here, and we are in location 1, we can narrow down what component is installed there. It might change in time. Some components can be switched around, but when we are doing this location, we have identified the component type, and then the diam type, so we can conduct the diam chain correctly in that case. And there's also other things to connect to each other. That's the whole idea of the database, but this is just the overview of the database, which is big part of the software development project. And then a little bit about the hardware we have decided. First, there was talks about using mobile tablets like iPad or Android-based tablet, but it turned out it was not so friendly to develop, and we ended up on this Windows-based Dell tablet which was used in the pilot project. And the good thing about Windows-based tablet, it can be used as a tablet, so it's easy to carry. It's quite small, can be put in a case, or you can put put it in or some kind of case you can carry it easily with you. And then also when you are back at the office, this can be used as a laptop easily. It comes with keyboard, and it can be easily connected to the outside bigger screen. And it's easy to synchronize database between this and the central database you have at the office. And about the connectivity, there's I know, like in TVO, you are quite strict about connectivity, so like wireless networks and Bluetooth and things like that. So we took that into consideration that those can be turned off, and this can be used totally offline. So this only has that database during the offline database during the inspection route, and when it's transported back into office, it can be synchronized with multiple methods in database. And then just, I don't bore you with too much technical details about the software side. This is just a few pointers. So it's a Windows-based software, both with the desktop side and tablet side. It's easy to make similar design, so it is regarding that. And C# was used as programming language. And this point about the database being agnostic, it's because TVO was used as a pilot project. I know what database they use, but if this someone else would be like to use this can be used essentially most databases. So if one site has some specific database or information about their plants and components, this should be easily integrated with those. And for the development part, my choice of database was this SQLite. So here's some concept pictures from the tablet side. So this situation would be that we have picked up the tablet, and we have a scheduled inspection. We are doing some specific route on one specific plant. It can be named something, and we have then the list of components we need to inspect. So we can guide the user through the locations, and in each locations we have specified the component. We have also database characterizing this component. We can show all the information specific to that, and then we can indicate similar way we did it in Excel, but this time we are at the site and we have the tablet. So we can do the indications here. So next slide should be that we have detected. This is the detection phase. So we have found some anomaly, and we can this list here we can show only the significant or relevant data here. So we can more easily make these lists more which are then easy to use with tablet and during the inspections. So that's pretty much about the concept. The user interface they are a bit crude, and the development got a bit delayed, and some of the user interfaces are not quite ready. But big part of the design work and the database is ready. So yeah, this is one slide. So this would be the step. I come back to this one. So first we were in the inspections, and we have the locations, and we made some markings, and then we came back to the office, and we synchronized the database in the tablet with the main database, and then we can see that these diam chains are not yet finished, and we need to complete them. So then the relevant party can go to the expert UI and from the main database generate the Excel view, which is represented here. So these would be the detections made during the route. There might be multiple detections, and there might be even some investigations that are done and findings related to that. And then we are left with one diam chain, and then the relevant party should be required to enter the rest of the data in the desktop interface. So that's pretty much it.